This is the tutorial for planetary gear. In this case, we gonna simulate a internal gear with a sun gear, planet gear, rotated by carrier. Um, Instead of gear mechanism evaluating CATIA kinematics, we are going to use roll curve joint to simulate this mechanism. So I will start with shaft, which will be major axis for the sun rotations. Then I'm going to start adding other parts as well. Sun, planet, carrier, and ring. Alright, to see the better view, I'm gonna just keep this angle. So I'm gonna send the axis a little back, and I'm gonna fix the ring. The ring will be actually present internal gear. This side will be gear, assuming, and there will be sun and planet linked by the carrier, and I will send the axis to the back, so they're gonna line at the back of the sun. So let me start with fixing the ring. Okay, ring is fixed, and I'm gonna coincident this face to this face. Then I am going to make this face also line up with this face, so they are about same level. So if I update now, you can see they're not actually coincident between axes yet, so we'll fix that soon. So let me manipulate. The planet up. We'll fix it later. So then axis of sun, axis of axis. And now the sun should be able to rotate it. Then sun and the carrier, I am going to make one axis to align with the axis of the sun, and the other side of axis aligned with axis of a planet. Axis to axis, and axis to this axis. And of course, so if I update it now, it's pretty good position already. I haven't added coins between those two yet, but the way the geometry made is already lined up, so it should be good to go. Alright, then let's jump into kinematics. So we're gonna go to DMU kinematics. Right, as I mentioned, we're gonna fix this ring and axis. So in this moment, you don't have to have fixed in the assembly. Matter of fact, you can choose another part as your fixed part. So new mechanism. Then I'm gonna fix axis. Then actually ring and axis, they should be in stationary positions. So the sun rotate, planet rotate based on these two ratio differences. So I'm gonna put rigid joint between axis and ring. So they're not gonna go anywhere. Then we're gonna have very simple revolute joint here. Then we're gonna make a revolute joint between sun and carrier. Same way revolute joint between planet and carrier. So revolute joint. So axis, and plane. Gonna hide and plane. Another one between carrier and sun. So axis. I'm gonna go to hidden place, axis, and plane, which will be back of carrier where it touched the sun. Then I can go to hidden place, and I'm gonna pick up the face where carrier touch. Okay, so I can bring it back. And another revolute joint will be between planet and carrier. So axis, and I'm gonna hide plane, go to hidden place, and this plane. Okay. So now, so far I made 3 revolute joint. Again, sun is rotating based on axis, which is already fixed, and the ring was rigid, so it's not gonna go anywhere. And another revolute joint, carrier and sun. Another revolute joint, carrier and planet. Okay. Now, with the assumption that all geometry are made properly, as you can see in the front view, you have to make, let me hide this one for you. You have to make the single point contact between two curves if you want to create the roll curve joint, which is this one, the roll curve joint. So we're going to use this joint to simulate a gear mechanism. Same way, internal gear from the ring part and this planetary gear, planet gear will actually have a single point. So again, it's important to understand to create a roll curve joint, you have to make a single contact point. So let me bring it back to carrier. So as you can see, based on the joint so far we have 3 degrees of freedom. That makes sense. The sun is free to rotate, carrier is free to rotate, planet free to rotate it, rest of them is fixed. So 3 degrees of freedom. So we're gonna make a relationship between this curve and this curve as a roll curve. And we're gonna make again this curve to this curve as a roll curve. So let's find out what kind of degree of freedom we're gonna have. So roll curve, first curve, sun, second curve, planet. Okay. So we have first one, then second one between planet and the internal gear. Okay. And now we have a degree of freedom. So with the assumption that sun will be linked to a motor, let's say it's a pinion, then by rotating this, it should cause rotation of a planet, and that should cause rotation of orbit of this planet by the internal gear, they should cause the carrier is actually spinning. So the axis of this carrier here will be actually output, input will be rotation of the sun. So with that, so our input, actual command will be revolute of our sun based on the shaft. So we're gonna make it as angle driven. We're gonna rotate perfect 360 degree. But as you can see, because of diameter differences and between planet and sun and planet and internal gear, there will be dramatic changes. So let me rotate about maybe 4 times. So 4 multiplied by 360 degrees. So sun will rotate 4 times. Then we're gonna find out how many rotation planet will make it, and carrier, how many rotation you will actually make rotations. So as soon as I say okay, then right away the system, this mechanism can be simulated. So let's see mechanisms. So 4 times the rotation of the sun. Then you can see planet is rotating, and due to that, as of course, you can see the carrier is rotating as well. Okay, so insert. So if I get rewind, there we go. So the carrier is making a little over 1 revolution for this full rotation of the sun. Keep in mind, if you now putting a law for the mechanism, if we spin that as, let's say, the 10 RPM, let's say that, then 10 multiply 1 minute per revolutions. 1 revolution. That is going to be RPM. Or you can say 360 degree divided by 1 minute. It will be again 10 RPM in the cases. Same. Then I can add the kinematic times so that we can have the same units for the both lines. Then say OK. So 10 RPM, the sun will rotate at 10 RPM over speed, and let's find out what kind of a speed we will get for carrier. Okay. So we're gonna add a sensor on the sun and on the carrier here, right there, and also add the planet. But one thing I'd like to mention is the axis we're checking the rotation of a planet shouldn't be based on the main axis. It should be based on the own axis in that case. So keep that in mind. So we're gonna add a sensor for sun. So base reference will be, let's say, axis, which is a fixed one. Then point of selection, we're gonna use the center origin point of the sun from the sketch in the case. There we go. So we're gonna keep checking based on the y-axis in the case. All right. First sensor is done. Second sensor will be added to the carrier right there. So we need to find out the speed of output. Shaft will be used as a reference. then I need the access to the origin, or if I had the reference point of a carrier, I don't think I have actually point here. Since my origin is right here, I need to find the center of this hole. Is there a way we can find? Again, sensor position should be center of this hole, which is actually my second hole in the carrier. So I'm going to use that so that I can track the rotation. So same thing, another sensor goes to the planet. Sensor reference will be, so that's the major point here. Now our reference is not axis anymore because the planet will be make a move, but I want to see the based on this axis how quickly planet is moving. So actually the reference will be the axis of this carrier, right? So with that fixed carrier, so as a carrier move, planet move, so then the point we are going to rotate and find out will be the center of our planet. So that's the difference. So be careful with that. Planet, oh, there we go. It's the center of this planet. Here's origin. Okay. So I just put the sensor on the planet, but it's going to be based on the carrier. Since carrier and planet moving together, then I'll be able to see the actual rotation based on carrier's y-axis in the cases. All right, so I think it is ready to go. Then we'll rotate with the law, which is a 10 RPM. Right? It's going to be 10 times 360 degrees divided by 1 minute. Then how long? Well, within a second, it will be again 10 RPM. So if I say it's going to be 1 minute, then I will be able to rotate 10 times, right? So I'm gonna make it as a 1 minute, which is 60 seconds. There we go. So if I run, so that's the speed of the sun within a minute. You're rotating 10 times. Then you can see planet itself is rotating, and they're causing move. Then it will cause move over this carrier rotations. So that's good. Then I'm gonna activate the sensor. And what we are looking for right now here is the axis, the rotation in y-axis. In this case, you can see it for the sun, right? Since the reference right here. And same thing for the carrier, then planet, but the related axis is not the main axis. Actually, axis of the carrier actually rotating. It will be good to have additional axis here. By adding the axis in part design, you can actually pick up those axes instead of a main axis system in the cases. So as an example, so if I'm tracking the sensor one which you added at the sun, so I'm gonna see angular speed of sun. Then I'm gonna see angular speed of y-axis. There we go. Of a second sensor, and last sensor again, angular speed. There we go. There I got the 3 separate angular speed, and we can kind of compare what kind of speed we are achieving with the 10 RPM of the sun and planet and carrier. Under the history, so if I start rotate, getting data, immediately you can see it. So sun is rotating 10 RPM. Then our carrier, which is the second one, is 2.94, less than 3. Then now we're getting another angle for the planet. In this moment, I'm not sure it's getting the proper angle with the difference between those two, and here 10.8 is right. I think we need to confirm that by adding the one more axis in the part. Maybe we can confirm that later. So the point in this simulation was utilizing the roll curve to simulate this gear mechanism, but internal gear was actually simulated with the roll curve. You don't have to really stick with the gear joint and the kinematics. Well, that concludes our tutorial.